So this is our second video over Cramer's rule. This time we are using Cramer's rule to solve a 3 by 3 system, okay? And using this rule to solve for any of the three variables of the system is no different than the setup would be when you were solving a 2 by 2 system using Cramer's rule, okay? So notice we're trying to solve for x in this system of equations. And then just to keep the video from getting too long, instead of solving for the other two variables, I'm simply just going to set up Cramer's rule for y and z and not actually evaluate, okay? So notice all three equations of my system are already in standard form, so that's perfect. And here would be the setup for the variable x, okay? So we know it's going to be a third order determinant over a third order determinant. In the denominator, you would have the following elements. They would be coefficients from the variables of each of the three equations in the system. Okay. And then in the numerator, my first column represents all of the coefficients from x being replaced with the constants. So 5, -1, and 1 make up that first column. But then the second and the third column, I keep those as the coefficients of y and of z. So -3, 2, -3, 1, 1, 2. Okay. And now I have two third order determinants that I have to evaluate. And recall, we have two methods for doing that. We can use either diagonals or expansion by minors. Okay. Now, I've been doing this, a long time now, and I found that while expansion by minors might be a little bit more work, it's easier to keep track of your work using expansion by minors than diagonals. So that's the approach that I'm going to take, okay? So I'll set up the numerator, take the element of 5 multiplied by its minor, subtracted by the element of -3 multiplied by its minor, added with the element of 1 multiplied by its minor. Okay. And I'll do the same setup in the bottom. Element of 2 multiplied by its minor, subtracted by -3 multiplied by its minor, added with the element of 1 multiplied by its minor. Okay, so notice I now have several second order determinants that I need to evaluate. This is going to become 5 times 7 plus 3 times -3 plus 1 times 1 all over 2 times 7 plus 3 times 1 plus 1 times -5. Okay. And then let's just continue to simplify both the numerator and the denominator. That's 35 minus 9 plus 1 all over 14 plus 3 minus 5. That's going to give us 27 over 12, which does not simplify out to be an integer. Instead, I'll just reduce it to 9/4. There we go. Okay, so let's say I now want to solve for y or for z, okay? So a couple different approaches you could take. You could use the value of x that we just found, so the 9/4, and you could plug it in to x in any of the three equations. And what you'd ultimately want to do is you'd want to pick two of the three equations to plug in for x. And what that'll do is it'll take those two equations from having three variables down to two variables. So once you have them in terms of two variables, you could solve that 2x2 system using Cramer's rule or any other method, substitution or elimination. Okay. Or you could simply use Cramer's rule to solve for y or for z in the 3x3 system. Okay. So the good thing is you already know what the denominator is going to turn out to be. It's going to be the same determinant as it was for the denominator of x. So that was a 12. Okay, it's just the numerator that will change a little bit. All right, so let's say we wanted to solve for y using Cramer's rule. Well, again, I know that 12 should be the determinant in the denominator, and then in the numerator I would have a first column of 2, 1, 1. Those are the coefficients of x. Since I'm solving for y, the middle column, instead of putting the coefficients of y, I would put the constants, which are 5, -1, and 1. And then the third column would be the coefficients from z, 1, 1, and 2. Okay, so there's your setup for y. And then for z, same thing for the denominator. We know it's going to be 12. And then the numerator, the first column will be 2, 1, 1, which is, again, the coefficients from x. The second column, the middle column, would be the coefficients from y, which are -3, 2, and -3. And then your final column would be, instead of the coefficients from z, they would be the constants. So 5, -1, and 1. Okay. So again, I'm not going to evaluate those just to keep the video a little bit shorter here, but you certainly could simplify those numerators just like we did for the numerator of x, and then you'd have your overall solution to the entire system. Okay.